U-substitution is a method for finding antiderivatives. It is used by algebraically simplifying a function in order to easily recognize the antiderivative. It is basically running the chain rule backwards. First, let's figure out what u in a function is. U is the antiderivative of a composite function. To put in simpler terms, u is the inner function. If there are two functions, u is the one whose derivative is the second function. Du is the derivative of u. So for example, in the example, the integral of square root 4x minus 1 dx, u would be 4x minus 1, and du, which is the derivative of u, would be 4 dx. In the next example, integral sine x cosine x dx, u would be sine x, and du would be cosine x dx. Although it may be tricky deciding which function is the correct one to choose, sin x would be the best function for u because the derivative of sin x is cosine x. A cosine x is already in the original problem.
In this problem, u is 4x minus 1, because that's the inside function. This makes du equal 4 dx. Since the goal in this problem is u du, to balance it, you need to multiply by 4 inside the integral and by 1/4 outside of the integral. Then you rewrite as 1/4 multiplied by the integral u to the 1/2 because of the square root times du. Then you take the antiderivative of u, making it u to the 3/2 over 3/2 plus c. Oh no. After this step, you'll replace u with 4x minus 1 and simplify to get the answer.
In this example, u is x plus 4, and this makes du 1. So substituting both for x plus 4 and for dx in the equation, we have the integral u to the 5th du. This integral can now be solved by using rules of antiderivatives that give u to the 6th over 6 plus c. And after this, we substitute u in and end up with quantity x plus 4 to the 6th over 6 plus c. This example will be involving definite integrals. The difference between definite integrals is that the final answer is a value and not a function. Therefore, it will not have a plus c. This example also shows u being an exponent and not just the inner function. U in this problem will be 3x plus 6, and du will be 3 dx. Because we are substituting u and du in for the function, we also need to change the limits in terms of x into terms of u. Both limits are plugged into u in order to get the new values. Once we get the problem simplified, we need to plug in the limits for u in the equation and solve. In this problem, u is x squared, and that makes du 2x dx. Since there's already an x in the inside of the function, you just need to multiply by 2 to balance, and then by 1/2 on the outside, and then you get 1/2 times the integral a to the u du. And then substitute, and since your constant is 2, you just substitute that in 1/2 integral 2 to the u du. And then using rules of integration, that's just 1/2 times 2 to the x squared over natural log of 2. U-substitution is a tool used very often in solving integrals in calculus. Many problems can be done much easier and with much less work. It's super fun.